recording now. Very good. So we're going to do this 4-fold pattern we did last time. Do you guys have the file? I don't know if you were here last time. I'm going to send you the file. Screen shooting away at the. Yes, there's a picture that we were using yesterday as reference. And it was.
Oh, yeah. The one from the Borgwens, however you pronounce it.
Yeah, I don't know how to pronounce the name either.
Yeah.
But precisely that one.
Okay.
Excuse me.
Yes.
Hear me?
Yes.
Ah, okay.
How are you?
Fine. Thank you for inviting me. Hi.
Okay, so I sent the file of the pattern we're going to be working on.
Mm-hmm.
So the idea of this pattern is to use the clues and references it has in order to. So I'm going to open it on the share screen here. I have it already zoomed in, but I'm going to zoom out a little bit so you can see it, how this tessellates. It's really nice. We have these octagons and whatnot. And, you know, there's no reason why we would be limited to thinking of it this way, having the center be the 12. We could just as well have the centers be these 4. And sort of like reverse engineer it from there as well. That's also a thing that could be done. But for now, we're going to stick to having it be this square, just as we did before. So we want to have, so let's analyze it a little bit. We're going to need a 12-fold division at the center, evident by the number of petals it has. And further analysis on it, well, we're lucky enough to have several construction lines there for us. So we have that line at the diagonal. So it goes from the midpoint of the edge all the way down to the other midpoint of the edge. And at the intersection with the middle there, with this diagonal here, that's where we will find the star we need. So that's a big clue in terms of figuring out this pattern. After that, we just need to find this line just to match this one, but we'll find that this is not as difficult as it might seem. And it's actually quite natural, this one. And what else? There was one more, and that's also in so the whole trick is in the diagonal. Notice how this diagonal line also hits the intersection of this little triangle here. So we're going to use this diagonal line, the 12-fold rotation, and that's pretty much it. Like, those 2 things are the clues, they're the keys to this pattern. But I noticed last time that there was a sort of, not a disconnect, but like there was a need for practicing in what a mirror is, because a mirror is pretty much like the tool, one of the more valuable tools in the toolbox. So I want to sort of take it back a little bit. And before we get into the pattern, I want to do a little exercise with you. It's just an exercise on folding, on mirroring. So before we go into the pattern itself, I want to start by folding this paper in half. And I'm going to fold the opposite corner to this line that goes to the middle here. So if I put my corner on the line and I slide it down, up and out, like up and down, I'm going to find that this line that hits the edge is going to change. So the idea is to slide it to such a point that I get the intersection at the corner of the paper. Now, the way I have it lined up, you'll notice that my center fold is in a mountain, and the fold I just did is in a valley. So we want to mirror this line now. Instead of doing whatever we did last time, we want to mirror this. So for mirroring, I'm going to mark, it's going to be this line, and it's going to be this mirror line. So for a mirror, first we fold the line we want to mirror. In this case, it's going to be this one. And now the next step is to fold the line we want to mirror from. So I'm going to turn the paper over, just because it's easier in this case to lift this up. So now I fold this down. And see, notice how the mirror line is going to change value. So it's going to go from being a valley into being a mountain. If I fold this up, boom, this line right here, between my thumb and my forefinger, that's the middle line. So that's going to be folded. So that's the line I already have. So when I fold it, naturally, all this is going to want to fold as well. So because of the size we did it in, we now see that this bounce goes here, hits the midline, and then bounces back off. So that's the idea of a mirror. So if we had something like, let's say for instance, we changed a certain value. So let's do again another line that cuts through here, but this time, so we're just gonna match this line onto that angle, to that fold. But this time we're not gonna fold all the way. We're just gonna fold onto the middle line. We hit the middle line, we stop. I went over there a little bit. And same trick. So first we fold the line we want to mirror. And now we fold the mirror line. So notice how the line in the middle, the mirror, is always being folded. The full line is always being folded. And see now for this case, it's a little bit cleaner because I didn't fold all the way.
Can you just redo that one from when we folded it to halfway?
This one?
So we folded it up to the half, yeah. And then what did I do?
I folded that. I folded onto the middle line there, which is the mirror line.
Yeah.
And then I just turned it over.
Okay.
And then I folded the mirror line.
Folded the mirror line.
So the mirror line is, in this case, the same as so it's this line that goes right through the center here. So if it helps to have that line written down,
oh yeah, yes,
recommend it. So now we have this. Let's see, the trick we're trying to sort of pull here is just to see and appreciate how lines can be bounced off of the same line. So if we did an arbitrary line, so I don't want to do an arbitrary line just like that, but I want to do a line that's a half. So that means that we're going to bisect one of these angles, but we need it to cross through this line. But let's see. So if we fold it in the half like this, not in half the paper, but half like between these two points. So a line that goes from here to here. That's pretty much, now that I have them marked, I can see very clearly that it ends there, it ends there. If I fold this down also, I'm going to see that this one's going to match with that one. So I have these mountains. Now what I want to do is I want to put this mountain onto the half here. So it's not completely folded, but that's fine, because I'm not going to completely fold the other one either. So I'm going to put this mountain that I do have onto the middle line. And again, I'm going just to partially fold. I'm going to fold, I'm going to stop at the middle. So I'm going to keep that folded, turn my paper over, and fold the mirror line. As you can see, we're going to have this incident. So that's what's cool about the mirror, because it has bilateral symmetry. These sorts of things will match up. So these will help us sort of get everything into position. You also see that it's sort of moving in a spiral fashion, sort of starting to swivel. And also the advantage of doing it this way is that it's a cleaner sort of fold. It doesn't go all the ways. We're just folding to where we wanted the line to bounce, and then we fold back. So I did this on this side.
Can I just ask you, sorry, that second, the bounce, I'm still...
This one or this one?
Yeah, no, the first one I got, and then to find where you want to bounce it off.
Well, I'm always bouncing it off this middle line.
Oh, the center one, okay.
Yeah, always, for this case. Okay. So I just fold it onto there. And even though the rest is like, I'm not folded, but it's fine, because once we activate the mirror line, we can see that it's...
So you fold it into the valley, or?
I made it opposite of the first line we folded. So it's just, if this is a mountain, then this is going to be a valley. So that it can go in, out, in,
got it wrong.
out. Yeah.
So I got it as two mountains. Okay, right. So I've got it as one valley now. Now, how do I take it to the other side? Yeah.
Okay, so you fold the one you want to bounce. So let's say you have this one.
Yeah. Yeah.
Now here's my mirror line. So I have this folded first, the one I want to bounce, and then I fold the mirror line. And then it sort of has to match up the back of it. But see, this line that's folded here it's the same mirror line, see? It's the same midpoint.
So I can do it when I follow what you're doing, but I can't seem to do it instinctively.
Oh no, that's fine. Oh, don't worry about that. This has like a certain level of difficulty. It really does. But at the same time, it's not supposed to be perfectly intuitive, but it is supposed to be something that you could perhaps see at this level. So you can see like, oh, okay, so there's like two sort of lines. So there's a line that sort of we're using for the bounce, and then the line that it bounces from. And so also, if you're noticing here, we're not holding all the way. So this is why we're stopping at this line and then bouncing off, so we can appreciate how much this line is just partial and bouncing. So what I did now over here, which is extend these lines, I did extend them all the way. But that's just so I can use the bottom. So we have a choice here. We have the choice of either putting this mountain onto this one, sort of making a rung. But right now I was sort of more attracted to the idea of having just the sequence of triangles, but only having the left side be going like this. So for instance, then it would be this one. Or you could also do it the other way, where you raise this one onto there. I'm going to fold only onto the half. So I'm just folding from here, and then I stop at this line, the mirror line. And then I can fold it. You see, but even though we have the same sort of effect here on the mirror, you see that it's sort of coming down. And then I'm sort of just aligning it. So I feel that this is the most useful tool in our toolbox. For at least for Islamic patterns, I feel that this one has the most potential and sort of utility. Just because of how much Islamic patterns depend on the idea of a line sort of stopping and going the other direction. But like the same way it came in, it goes out. So it's very much like optics, like light that behaves this way as well. So now just for kicks, just for fun, I'm going to put this one also. Again, I fold and I stop at the middle line. Then I fold the whole thing back. And see, here you're actually seeing how the whole line is being folded. So there are several exercises we can do with this mirror line. I just really like the 6-fold division. It's very natural, it's very nice. So this is the sort of thing that also could be done when you fold one way in and one way out on the same figure. You get this drum and you do this thing that's called the petal fold. And well, you also notice that if we fold these two together, like they'll have a little incidence there. So that if they're hitting, they won't actually fall flat. Rather, they would have these two edges sort of meet, hit. Now, just to end this for now, so we can move on to the Islamic pattern. But I'm going to add another mirror line. So let's say either that this could be a third line, or this could be a half line. So just for right now, just for our intents and purposes, I'm going to just do a half line. I'm going to fold it one way, turn it over. Then I'm going to fold the other way. And so the reason I did both of the folds is because it usually exchanges anyway. So a mirror line can be folded both ways and you can get a little more time save there. So now let's say that I bounce all these lines that intersect with it, I want to bounce off.
Do you just refold the same line the other direction?
Yeah, same lines. This line is folded both ways. So I folded it in a valley and I folded it in a mountain. And now what I want to do is I want to bounce all the lines that hit, all the lines I want to bounce. So for instance, first line that comes in, it's this one. So I can fold it, and then fold. So that's one. I fold this. Also notice how I'm sort of extending it towards the edge that I need to fold it in. So always mind your mirror. The mirror is the most important aspect of this.
Mhm.
This one's trickier because I don't have the full line, but since I don't really need this on my left here, I just really focus in on my right. And I'm making this ribbon shapes, which I suspect are actually like part of the Islamic pattern sort of shape canon. So of course we could also extend this one down and get the rest of the lines in, so we have this sort of like the same shape going downwards, but we also get to see how a specific mirror can change the whole thing quite a lot. And also this is quite interesting. If we start to fold it down and collapse it, well, first off, we're going to see that there's going to be some overlap here that's needed. See that? Goes one way. And so as I descend it, I find that on this shape, this one actually is extending all the way to becoming a star here. So I think that this looks really nice, this sort of complementing with the back there. But if we copy the same sort of mirror now over here, then we have sort of this ribbon pattern happening. So it's a fun way of playing around with half angles. So we did this bisection, but you don't get to see the conclusion of it. So you sort of like lose track of where it was going to go. And then when it bounces back, it becomes this whole other thing. So yeah, mirrors, very useful. So we're going to put this aside for now. So you can keep this going later if you wish. Try to find like combinations of the mirrors. You can always also cut the mirror in a different direction. That is either a different segment, or whether it be folding this into thirds. So if you're wondering how to fold this into thirds, we're just going to use a certain property of the triangle. So I'm just going to do a little fold here. I'm just going to do like a fold around there. And then I'm going to put my paper here, fold around here. And this intersection, like the center of this triangle, the line that goes from the corner there and the other corner down, that point, if I get half of it, that's a third. So that means that if I take this point and I put it on that point like this, the line I've just folded is a third of this fold line. So I can go one, and then I can put that fold onto the fold that's over there if I wanted to keep the same sort of state. And you'll see that this point will fall in the center of this triangle if I had that line. I can fold that as well. And now I can bounce those, right, if I wanted to. Because this one I couldn't bounce. So why can't I bounce this one? Well, the answer is that because it doesn't intersect with the mirror line. But what I can do is I can fold it. I can fold the mirror line, and you're going to see how it's on the back here. So even though the line doesn't intersect, I can still use that fold as a reference. Just in using this mirror line because of the bilateral symmetry. But when the line does intersect, that's when I can sort of activate the fold in order to use it. So this tool is one of the most useful for constructing Islamic patterns, and it's a hard one to master, and there's certainly different levels to it. So the way we're doing it here is we're mirroring off of vertical lines. That's how it's going in this sense. But the one we're going to do, the Islamic pattern requires us to fold to mirror along vertical lines. So we're going to take another piece of paper out. And well, I have this one that's already sort of has one pre-crease, which is just a square of it, because I'm going to cut the square out, because that's our clue. So everybody got sort of clear on how mirrors sort of work? Sort of?
I see them sometimes and I don't always. Sometimes it just happens and then other times it goes. So no, I can't see it clearly.
It's a fun game. Like when you play this game of the angles and just bouncing it off the half and adding new mirror lines, it's...
Yeah, I think I can see what, I'm aiming for, but I just can't seem to do the folds in the right way.
Yeah, it takes some playing around with it to sort of get it to be second nature. Most definitely. So okay, we have the square. So first key, get a 12-fold at the center. Now there's several ways that we can do this, and so I want to go over several of them. Well, because it's useful for you to have more tools, better results, kind of thing. So it's easy to put a 12-fold division at the corner. That's easy. So we're gonna try and do that. We're gonna try to take advantage of that. But first, we're gonna get the center of our square. Now this is different from what we did Monday. It's gonna be the same thing. We're just gonna change the process up a little bit. So the way we did it Monday was getting this and then doing the preliminary fold. So that means that we had two mountains across diagonally. And then here, I'm just holding these 2 points between the edges by eye. I'm holding them and then I'm just pushing my fingers forward. And then I'm grabbing these, closing that in. Just bringing the whole thing down. And then I can open it up like this. And then I put my fingers again between. I grab these two. And so I'm hinging and I'm moving around this point. So again, the way we did it on Monday, it was pretty much sort of trisecting this angle, this flap, this fin. That was a trick we did, but today I want to try a new trick with you guys. And in spirit of the mirrors, you'll see. You tell me which is simpler for you, but I'm going to teach you both. But here's how it goes. We're going to take one of the corners, and we're going to do the 6-fold division. This one. So again, I'm going to put it on the middle line, like a slider, and I'm going to find which point on this line matches for this corner over here to be at the corner. If you want to fold it only partially, that's fine too, because we're not going to use the whole line. So now we want to bounce this so that it gets to here. So what could be an idea? Well, I'm going to turn the paper over. It doesn't matter which way we fold. We're going to fold it both ways. But if I were just to fold it one way, I would fold it opposite of whatever this is, because for it to be a mirror, I need to use it. I need it to be opposite. So when I fold my corner to the center, look what's happening. I'm translating. I'm putting this angle at the center. You can even see it there. So now I want to do this line and bounce it towards the center. So I'm going to fold this line, and then I'm going to put that onto the center. And everything that's after this line, I'm going to fold back.
Sorry, everything after which? One step back?
Yes, so this 12-fold division that goes from the corner, yeah.
Uh-huh.
And then we put the corner of that onto the center of the paper like so.
Yes.
And so everything that's behind this fold,
Oh yeah.
we're folding it back. And when you do, you'll find that here on the top, that's the mirror line. So you just sort of aim it correctly so that this one actually goes through the center as well. And that's where you fold.
Fold that all the way down?
Yeah, because this is part of the 12-fold center division. So that's actually going to go through the center.
Oh,
or
yeah.
it should go through the center, and we can extend this one even further.
Okay.
So this is a nice trick of using bounces, because it's easier to put a 12-fold division on the corner of the square than it is on the center. But it is easy to just put that corner onto the center and using the mirror as a tool again. So we're going to use, so in my case, I have that the diagonal and this 12-fold fold that I have are opposites. So that means that this line that goes here is a valley, and this one that's over here is a mountain. And so what I can do now is sort of just...
It's gone a bit fuzzy, okay.
Sort of compensate for it.
Hang on, let me just get my...
So it's almost as if I had it like this, and then I folded this diagonal line, and then I hold it here, and I just put that to match. And then I can turn it over. I'm noticing here that it's going to need a little bit, just some little push just to get to the center.
Oh, you do it on the other side as well?
Yes, that's like, it's a sort of mirroring, but it's almost, it's to get these two to be copied. And again, like this is sort of, so we did like a half trick, because the other way that we could have done it is to actually like complete the 12-fold here. Like this angle, completely fold the 12-fold and then translate that and just mirror everything off of this. But we just did one, and then from this one, everything else is going to spring from. So we have this together like so. And now we have these hinges. So you can just fold these down. So I fold, I unfold, and do the other side as well.
Should they land on the 90-degree line?
No.
No, okay, because mine don't.
Yeah, mine neither.
do it on the other side as well?
Yeah. Although now they mention it, well, they should, because it's a trisection, so all these should be equal.
Mine are really quite out.
Oof, mine too. So okay, no, we're gonna do it another way. So this is like theoretically right, but I guess like somewhere along the way, everything just became like the mirror is not a fail-safe. So let's do it this other way. So I'm gonna take out another square piece of paper. I'm sorry.
The
But we're
problem
learning.
is should have been on the vertical line exactly.
Yes, that if we got it correct, we should have gotten it there. So we're gonna do this another way.
Okay, let me just.
So I guess this also goes to show how the mirror is not this fail-safe. Like it's not always perfect. It requires some tinkering around, and it's easy to miss.
I think when you're folding it over a couple of layers worth, maybe.
Well, that definitely changes the accuracy of it. And when we're done, I'm probably gonna go back to that one that I have here, this one that didn't turn out right, and try to fix it. So again, I'm going to the preliminary fold. Okay, so now there's two ways to fold the preliminary fold. It goes either in a square fashion, it looks like a square here, or it looks like half a square. The half a square is if you open it so much that it starts closing in on the other side. We're looking for the one, this one. So now what we want to do is trisect these fins. So here's how you do a trisection with these fins. You open up this fin like so. Make sure that this line is adequately together. And then you're going to do a pinch. So instead of just bringing it down, we don't do that. No. We pinch it. I'm going to take my fingers down and take them down in such a way just so I'm sort of creasing so that the fold knows where to go, because I want it to go at the center as much as possible. And then I take my pinch and I sort of bring it down towards itself like that onto one side. And now I'm looking for the fact that it comes from the center over there, and that when it falls, this line falls on the center and the other side falls on the other, like it's excess. So after you've done this, you can just push like this pinch that we did. We can then do it to the other side. Again, just making sure that it goes towards the center. Like this is as spiky as we can make it. And if we did it correctly, this pinch should also fall on this other edge over here, on this other fold. and this line should fall on the middle.
The middle is a difficult point.
Yeah, our center.
Not very exact.
So once we have this split into threes, now we can go to the next one. So we have this one, and then we can go to the next fin. And the advantage of doing one that's correct is that, well, that's all you need really. So now I'm going to take it down, but instead of pinching it, I can just sort of arrange it on this fold line like this.
That's assuming it's accurate to start with.
Then I can take this edge. Again, when I fold it, I'm also making sure that these two are together and that these fall right to the center over there. And then to the left.
Doing our best.
And see, now that I have half of it, so I folded 2 of the 4 are now in 12s. Now in 3s. So what I can do, instead of doing it for all of them, I'm going to open it up. And see, now half of my paper already has my trisections. So what I can do now is just extend these lines. And that will also save me some stress. So I have this line already, and I just have to fold it and then just extend it. The next one. And see, I'm also making sure that these line up. So that's the advantage of just spinning it around using this method, that you can always be pivoting and making sure that everything is just lined up. For the 12-fold division at the center, I feel that this is better than the mirror method. So there I've done the 12-fold at the center. And now what one can do is also try to sort of now collapse it. So because we have just mountains and valleys, and just to make sure, you know, just to fold it in on itself. Make sure that it's all nice and balanced. So because of how many flaps this has, it tends to sort of counterbalance because it's too much stress on the center, as you can tell. Like so many little things that, you know, it offsets a little bit and then one of them just falls out of line. Like for instance, I got one that falls out of line here. This one also sort of falls out of line over there, sort of, like a little bit. So I'm not gonna, I feel like, yeah, we're an hour in, we got our 12 fold. How you guys doing? You got your 12 fold? Division at the center?
Yes.
Awesome. So there's another way to get this 12 fold, but I'm gonna save it for a little bit after. But for right now, we're gonna focus on this 12 fold. So that's first clue. We're done. Awesome. So now next point, we need to have the center, the diagonals of these little squares that we have here. So we're just gonna fold corner to the center.
Does it matter which is which direction?
Yes, we're gonna see which one it is. It can be both, but for right now, I'm going for making it the same as the diagonal that crosses this. So if this is my valley, I'm also doing this one in a valley.
That's what I had.
So how's everybody doing today? Good day? Good Wednesday?
Should be working right now.
This is like working, it's learning. So I'm just gonna pull up the image again, just to show you guys something. So now we got to figure out which star this is. So we're looking at this. We got the point of incidence. We already have this on our paper. See. So we have this point right here. Okay. So which star is this? We go 0, 1, 2, 3, 4, and you can see that that's a straight line. So again, it goes 0, 1, 2, 3, 4. So if we look at ours, we're going to count, well, on mine, I'm going to count valleys. So I go 0, 1, 2, 3, and 4. So our line of the star is going to go through this point, and it's going to sort of match there. But see, the line is going to be perpendicular to this one because it's right at the middle. So these are going to be like a cross. So now I have, so when we fold, or in origami, if we want to get a perpendicular line, when you fold the line onto itself like so, so this line is going straight, I'm folding it on, it'll give me a perpendicular. And this could be any fold. It could be just like a fold that's there, like that. And if I just fold that fold on itself, so just making sure that line goes straight when I fold it, the resulting fold will be a perpendicular. So that means that this line that I have here right between, this whole line, I'm going to mark it on both sides just so you guys can see, but I'm going to, you don't have to if you don't want to. This is just for reference, but I'm going to do it on both sides just so you guys can really see how this falls on itself. So again, keeping in mind goes 0, 1, 2, 3, 4.
1 minute.
Yes.
Let me just mark it all.
Now the reason I'm going to mark it all is just so I can, you know, see that it falls on itself, that I don't get lost on it. And you know, it's pencil, it can be easily be erased. And I'm also going to mark the intersection of this cross point on both sides, again, just so you guys can see. So I have at this point, I need a line that's perpendicular to this line. So I'm like, I hold my finger at that point, my cross, what I'm aiming at. And then I can see it on the other side as well. I can see that it's coming in. I can see that it's coming out. So I line it up. And then I'm also making sure that this line extends fully. You're going to see that several things happen. For instance, apparently this point, it hits, but it's not the same line, but it hits and sort of bounces off. So we got a coincidence here. This line matches as well. But again, the most important thing is that it goes through our mark. Now,
Did that happen?
Hmm?
Sorry, mine's
So now I'm going to reverse this fold because it's the same. Right now it's the same as this diagonal line, but I'm going to use this diagonal line as a mirror. That's one way of doing it.
Can I just go back one step? Was it 0 and 4 that line up?
Is it 0 and 4?
So the line is going through 0 and 4 diagonals?
This,
you marked them, yeah?
Yeah.
1, 2, 3, 4.
Yeah, that's true, yeah.
Mine seems quite way off.
I mean, if you
like
do
about half a centimetre.
But
because my 12 fold were probably not accurate.
But I think also, like, I keep more in mind that it goes just through this point over here, and that this is a perpendicular. So 4 should be, we don't know where we're hitting really. We're just making sure that it's a perpendicular. Does that make sense?
So it's more about it being perpendicular.
Oh, definitely, definitely. Because we don't have the point at 4 where this is going to land. So we just care that it's a perpendicular, this line.
So we take it from 0 and perpendicular?
That's correct. Perpendicular, but at 2. So it goes 0, 1, 2. And now making sure that this line that we have folded here for the star is going through opposite. So you see now the advantage of having this line be opposite of this diagonal is that it's also going to be opposite of this center fold. So we can just apply a quick trick. We go from here and we just sort of, we can copy this. So this is like a two birds with one stone kind of thing. So you see with this line that I've copied over here, I've got the one on the other side as well.
Yep.
So now what we can do is we have this line that goes through this point that we cared about. And so now we can bounce it as a mirror. So I'm going to use this line that we have here. And I'm going to use this as my mirror line.
Sorry, just open it back up again. Sorry,
Yes.
I just missed.
So it's a diagonal line.
Okay.
And so that's going to be my mirror line.
Oh, it's gone fuzzy. Diagonal. Oh, yeah.
And so you get this bulb, you get this thing that's sort of like jumping out at you. But you have this other side, and because it's bilateral, the symmetry, you can just match that to that one, really. Unfold, and we get this thing right here.
Mm-hmm.
So this line, we can extend it, and we should extend it because it's going to keep going. And now again, we get the two birds from one stone kind of idea. We get this, and then we can fold this down, which is parallel. So these two lines are parallel.
Yeah.
So now we can use the back of it.
Just 1 minute, 1 minute.
Mm-hmm.
No, I haven't got that fold. So I've got the two. Yeah.
You got this one though?
Yes.
And you got this
Yeah.
one that's parallel.
Oh, yes.
So you sort of like shrug together.
Yeah, I've got that.
And then you can use the shadow on the back there. This line that's here. And you can just lift it. So you see how this, so when I lift it, I'm just making sure that it falls on this one on the back there. So now we've got two that are complete. These two opposites, they got their lines going through them. So that's very good. Now, I noticed this yesterday. So we could do a bounce and, just be done with it like this one and bounce it off of this triangular. All right, just make another triangle there. But I found this very nice relationship where it goes from the corner here, from this corner, the bottom, to our X mark over here. And that completes our triangle.
Oh, yes.
So we're looking for these 4 triangles. So the advantages with this trick I just showed you, we also have another way of looking at it. That is, we have 4 very clear, very accessible solutions. We have just put the corner onto the other side, and that's your solution, you know. So I have 1 hexagram, we need to do the other hexagram. Because it's 2, right? Because it's a dodecagon. So we have, I'm done with these 2. Now I'm going to do these 2.
I somehow missed joining up that second, so I just got to do that. Completing that second triangle. 1 minute.
Mm-hmm.
Okay.
We folded this corner onto the opposite midpoint of the opposite quadrant. And we're going to do it for the same, but on the other side. So it's this one. It's going to hit that one.
What is it going to hit?
It's going to hit the midpoint.
Oh, yes. Of that. Yeah.
Of this other quadrant. So it's the advantage of this line. If we just fold that line and we turn it over, we can even actually see the lines we need. So it's like the furthest one that intersect with it.
Yeah.
Of the radial line. So those are our mirrors. Just fold that down. Instead of actually unfolding this one and extending, we can just unfold it, return to this state, and then do the other one. How are you doing, Sharmina?
I got that one, and then I think you carried on and I got lost.
Okay, so I did that one, right? And now I have that it goes from the center, right? And then I have this radial line, the last one that touches it. The next one goes further from it, see? So I have my center there, my 12-fold center here.
Yeah, I've got the center.
Okay.
What have you folded underneath? Where was that?
Oh, this is the...
Oh, so I have... Okay, I've got that.
Okay,
Yeah,
so I
folded
fold that. I turned it over.
Yeah.
Go center, 12-fold
Yeah,
division.
I've drawn those 2. Yeah.
Okay, so you just fold that and mirror that.
So you do that on both sides then?
Exactly, exactly. So that will give us the full triangle, see?
So I've got 1 and then...
Mind the radial lines, mind the radial lines. You see that's going to be the last intersection of it. So like the radial line is going here, it's a valley. And then the next one that comes in, it's a mountain, but it goes way off. So it's the last radial line to intersect. The other one is here and the other one is here. So I do it on that side and then I do it on the other side. This is the hardest part, by the way. Just getting this star in is the hardest part. So if you're following along, you're doing great. You're doing great. You can handle it. You can do it. You gotta believe. Now, there are always several solutions to anything. There's not just one thing and we're married to it and we got to compromise for it. Rather, there are several ways. And so once we solve it, like we're doing now, we can always try to find other ways that we could have gotten to that point, or rather to this line. So for instance, just as much as when we get one, we can get the other, right? Just by mirroring, right? So if we've done this triangle, instead of doing the other side, what we can do also, so we just copy this one, right? Just as much as we did over here with these.
So your mirror is just your line of symmetry.
Mm-hmm.
Okay.
And again, you're going to see how a lot of lines match up. So that's also a big clue. This one falls right on the edge there. This one extends. This one extends. Again, I say this one is like, what is that line? But when you see it on yours, you should like try to keep an eye out open for relationships. So anything. But you gotta keep an eye out for it. And so with something so symmetrical as the dodecagon and the dodecagram inside of a square of all things, so this is very symmetrical. A lot of things are gonna tend to pop out. They tend to have these nice relationships. When you're folding something weird like the heptagon or the pentagon, sometimes the thing you think is a relationship isn't. And sometimes you're gonna see that things just like very slightly are shifted or swiveled or just slightly out of reach. But in this case, we're taking advantage that this is very, very symmetrical. So we have our star, right?
So I'm missing that, sorry, that final triangle again. I can see where I
So
want it
if you have
to go.
one triangle, you can get the other by using the radial line like so. So if you have, let's say, this one,
yeah.
or rather maybe one a weird one. So if I have this one, I can then fold this middle line like so, and then just fold that using the edge of it, because just as much as it's on one side, it's going to be on the other side.
See, I think last time we had the dodecagon folded in, so I could see where they need to end, whereas
Yeah, no, this we just have a point. So in here we just have this. So if paper wasn't a 3D object, that is, if this could just be like folded on itself and height wouldn't increase, you know, if it was theoretically 0, you could really just have this fold be, just have everything on the 12th fold and just do one single fold and everything would just fall into place. So what I mean by that is,
so that's this one.
if this could just be folded here, if I could just fold it in without any resistance, and if the fold could actually like go right through, I just need one, and then I could just put it here and then just fold everything. But because paper is a 3D object and everything just sort of compounds, I can't do it. I can't do it like that. I got to do one by one, especially if I got to be precise about it. But in here we have this just a very clear-cut case of where we want to go. So another thing that you could do, you know, if you're so inclined, you could take a compass. You take a compass. This is your radius. You know, well, the thing is, like, using a compass on a folded piece of paper, it's kind of difficult because of all these mounted ridges. So what you can do, if you were to use a compass, well, you just fold all the folds to be both folds. So all the folds you just need. So this mountain needs to be a valley. This valley needs to be a mountain. Just have it both ways, and that neutralizes the effect it has. So this is quite prominent because it's only a mountain. But if I applied a valley, like if I applied it as a valley, it would change. Like there would be this, it would become flat. It would be neutralized, I call it. So I'm just fixing one of these lines because it apparently didn't meet the criteria of going through this point. So point, point, point. So all these are going, these four are going through those midlines. So if I fold this down as well, you can get to pretty much see how this is going to go down. Now, if I have this folded down like this, like we did before, and I start to fold it, you're going to see that there are way more relationships. See that? It's just the see like having these four folded down is just like, you know, it just matches with the radial lines. Now, the reason I don't prefer this method is just because of the overlap. But by doing it, you get to see, like, this is an example of a solution sort of coming in and out of the blue, and see how this is just the middle between these two. But see, but you have this excess. That's why I don't do it, because it has this excessive piece of it. You just risk on influencing too much. But you get to see how this is just quite more natural. You get to see that, right? So just an idea, maybe for next time. But like, again, we having a perpendicular and we have a landing point. So just an idea. Although, yeah, it's an idea we're gonna need to have. This is good. So we're gonna fold these four like this.
Right.
And we're going to fold the star into it. Now, just make sure as much as possible that these stay touching the center as much as possible. Just make sure that
I was still drawing my line. So you folded
the star. So I folded, yeah,
where? Oh yeah, I've got to. Yeah, folded those in. Okay.
So corners to the center.
Yeah.
And now on this side, I'm just going to refold the star. So just the star, I'm just going to refold, making sure that everything is.
Is that to get the folds on the other side?
Yes, indeed.
But you've got to make sure that they don't move.
It's, yeah, just get it to be as exact as possible, because it's not really on that layer, but yeah, it is. But you can always like fold it and then turn it back and then just pull at it and just make sure that it's on the center. So this is kind of like the beauty of the origami of the fold. So you can sort of use several layers at the same time, and so one solution just breeds all the others. So it's a very nice feeling, actually. And when one does these kinds of solutions, one starts to wonder, are there others? Is it my lack of imagination? And so you get to see that. And now when we unfold it, what's cool about that is we pretty much just, we've completed these triangles here. So now we can just extend these lines. So it's the one that forms the triangles here, these ones, we can just extend them. So we extend, extend.
It was missing one.
When you do the fold, you're going to see how also there's another relationship. That is, this one is falling on the star, so is this one. Although I am going to do this fold the other way because I want every line of my pattern to be a valley. So I'm going to turn it over. Just, you know, one fold and goes same fold that I have already. Match it up.
Oops.
So first thing that strikes me is that because of what the mirrors we did, you pretty much just have this same star, but over here, you can see how this one, there's a petal, there's this irregular pentagon, but the pattern we're doing has one more line, and that line is like crucial to this thing. But here's another point. So we need this line right here. So we're almost done. You see, we got the triangles, we got the center star. It's looking great.
Yeah.
Now what we need is just the point that intersects with the radial line and the other one. So going back, that means we need, so if I just keep if I draw in my lines for like on the triangles here, I will stop where they hit the radial line. So at there I stop. So I need a line that goes from here to here, from here to here. So one could mirror this on here, but again, I could just match these two, lift, and on the back side, just keep an eye out for the intersection. You're gonna see both lines. You're gonna see both lines coming in, coming in, coming in, coming in, and you just line it up and so yesterday, Shamina and I, we were present in this J. Bonner Akio Hasume conference that this company in Turkey that makes tiles organized, and it was great, very beautiful. And Jay Bonner was talking about his book and talking about Islamic patterns, and the idea was quasi-periodicity, which is something that is very interesting to me. It's something that has called my attention for quite some time now. And they didn't touch on it as much. I thought, I don't know why, but before at the conference, I thought that Aki was somebody else. And then when I saw him, I was like, oh, so super excited because I've been following this guy for years. But they really just talked about their own sort of field of work. and they're both artists. Like one of them is an architect and the other one is an artist, pretty much, an Islamic artist. And so they're talking about how these shapes sort of fall into certain categories of study that are similar to that of quasi-crystals. Now, if you're not familiar with quasi-crystals, I recommend the book The Second Kind of Impossible, The Search for the Quest or the Search for a New Type of Matter by Paul Steinhardt. That one just really goes into the paradigm shift that occurred in the 1980s when quasi-crystals were discovered. And so that's around the time that Akio actually started working with the Penrose tilings. Now, the Penrose tilings were around since the 70s, not the 80s. Like the Penrose tilings came before the quasi-crystals were discovered. But they were a nice framework for what was possible. So tilings themselves are the limitation of quasi-crystal order. So they're these packets of matter that are so orderly that if that diverging from that order is considered to be impossible. And so when in the 80s it was discovered that a crystal could actually organize itself in this tenfold way, they actually fired this guy. They told him he was crazy, that he was wasting company resources and money and time, and they just fired him. So he was studying this alloy of aluminium and magnesium at a certain temperature in water, because apparently like the crystal will change on which liquid or like place it is and at which temperature it is. So it was a specific temperature, it was a specific combination of metal, and it turned out that he could get tenfold symmetry on it. So he showed it to his superiors and his peers, and they told him that it was impossible, that he must have made a mistake. But he kept repeating the process, and it was a mistake, it was a mistake. So no, it wasn't a mistake. Like it just came back tenfold. It was just science. But they weren't ready to accept that there was something fundamentally wrong with the way that we understood crystals. And what's interesting about the study of crystals is how much that relates to our study of geometry and our study of what we call not graph theory, Galois theory. So there's several branches of mathematics that deal with the way that things fall into order. And so for all these things to be questioned was not something that a lot of people were ready to do. Next step, and last step too. We just need the kite shape that is appearing here. So if we look at our diagram once more, we're going to see another clue. The clue is right here, right under our nose. So what angle does this look like? That's a right angle, right? So a right angle is a perpendicular. So that means that we got ourselves something to look for. So if we look at the line, we see that this line is perpendicular to this one. So we're going to look at ours now. And so we're going to take advantage of the fact that the line we're going to need as a perpendicular is now sort of dragged on the stars because they're parallel. So what I'm going to do is I'm going to make sure that this line falls on itself. There's one of the star right here. And that it falls on this point. Well, also, if you got like a keen eye for these shapes, we've got a rosette, by the way. If you continue this line and then just bounce back like this, you can just combine this triangle with this other shape, just like the half of a hexagon, and you get your little rosette. See that? If you were so inclined. You can complete it over here. You know, it's an idea. It's an idea. Also like to keep an eye out when we're folding these patterns. I encourage you to keep an eye out for other patterns because they're there. So again, star line falls on itself, and when it does, this one falls there. And also, just so happens that this line is exactly where it's at. So our fold is going to be right where this line hits, the one that comes from over here. At this point, on the very edge, and then the star line that is parallel to it is going to fall on it, and it's going to fall right on there, right on the top of the rosette figure shape. So once we have that, we can then use the fold that's there as a sort of complement to it. You can do an overlap and you just unfold and extend, and we're cooking. That's pretty much it. So now just to draw in how that looks. But again, like what's cool about these is that there's no like, you know, truly final and correct shape. We have options. So the option we went for is the one found in the book. There's a book called, I think, Persian Patterns. Persian Patterns and Design by J. Vojoi. I always mispronounce his name. Vojoi. Arabic Geometrical Pattern and Design. Published in 2012. So what's cool about this book is that it has these references. It doesn't have instructions, but these are enough, like especially with folding. Like the idea that I'm sort of trying to impart on you guys is to sort of see this from another point of view, another perspective, in order so that all you really need are these radial lines and some reference points. Because that really opens up the world of Islamic design, because then you don't need no tutorials. I mean, you could even like sort of reverse engineer the thing, which is something that's quite interesting to me. And so of all the radial lines that are happening in our pattern, well, not the radial lines, the star lines, sorry. In our pattern, these are the only ones that get cut off. These are the only ones that have a bounce. So all the other lines in this specific pattern that we're trying to do right now, all the other lines of the star simply just go all the way. So this one, for instance, goes all the way. This one over here, all the way. So all these lines go all the way, except, of course, you know, in Islamic pattern tradition, when we hit the petal, that's when we bounce off. So we just, you know, you just stop at the line of the petal. So all the lines that go after the petal are gone. And so, yeah, so I thought they were going to go into some of the quasi-crystal structures. They did go into, so Jay Bonner has in his book several suggestions on how the polygonal method can be used. And he goes, after he sort of establishes the basis of it, he then introduces the idea of the rhombi. He calls it rhombi. And these rhombi, we've talked about them actually, and they pertain a lot to the theory. So there was this discovery made by a person called Robert Ammon in the 1980s, and it was completely independent. It was just like a fun recreational mathematics kind of thing. But the idea was that you could decorate a shape in such a way that, like, only with straight lines, just straight lines on your pattern, and then you would match the rest of the shapes if the straight line kept going straight. So there were these sets of parallel lines, and he discovered, I think he discovered two sets, like two symmetries of it, but several sets of them, several decorations for different shapes. And he came up with his own shapes. And those are known as the Yaman Patterns. And they have just like the paper. It's kind of confusing because they're named like A1, A2, A3, A4, A5. So just like the European paper, he was American. So he didn't have that sort of reference, and it's named after him. So that's the A. So all these patterns are quasi-periodic, aperiodic. I get confused on which is which, what's the difference, but they're used interchangeably almost sometimes. And what's interesting about those kinds of patterns is that they suggest the possibility of variety, like something like you could choose what's where and have it match and still be able to change it. So what's beautiful about that, at least for me, is that a pattern is not one pattern, but like it could be many patterns. And what defines that pattern is your choice. What the designer chooses that pattern to be is what that pattern is going to be. And it's going to fall into the aesthetic, it's going to fall into the theory. And that just opens up this door of infinity, because it's not only the pattern or the sequence that you can sort of match and just keep on going forever in the square, but it's the idea that how you sort of make it happen is also part of the infinity it has. So that's what I really like about it. So the way that these work in sort of the structure of crystals is that you're looking for higher dimensional order. So usually these patterns, at least the patterns that retain to the quasi-crystalline figures, they are resembling in lower dimensions, higher dimensional order. So for instance, the Penrose tilings, properly aligned, could actually represent a 3D figure. And if you look at my profile picture on Zoom here, that's a quasi-crystal. There's a picture, an actual picture of a quasi-crystal. I think it's, I don't know how many nanometers long, but it's very, very, very small. It looks like flowers. I love that picture. I forget which compound it is. So I was looking at this pattern, and I'm going to send you another picture of this pattern. But this other pattern, it's the same pattern, but it's found inside of a different base. So I'm sending you the second picture of the thing. Let me know if you only got one. Like in the second picture, you're going to see that it looks similar, except that it's inside of like the length of a hexagon. You're going to see that it's two equilateral triangles on top of each other. And why I really like this construction is because if we were to match, like put a, almost, let me see. Yeah. So if we were to match, so we have this same pattern, but on the height of a hexagon. If we were to match it, that is, put a square underneath here. So instead of just making this pattern continue on towards infinity with itself, rather put a square here, a square like the one we just made. So the difference being that the one we have does not have stars at the end here, but they're there. You know, we saw that when we folded these in, that we have actually the possibility, if we wanted to, of having this pattern be like a double rosette. Like this is going to come down, this is going to bounce back, this come down. So you see that almost? You get to see how this lines here, if we chose, instead of having the full dodecagon, which is why this pattern is the way it is, we're choosing for the full dodecagon. But if we didn't, just kept on this big looking sort of octagon looking thing, we have the possibility of having another center here. So then it would match with the other example that I showed you. So then we could have height of hexagon, square, square, and it just so happens that that is the symmetry of something called the platinum rectangle. Now the platinum rectangle, I found it by getting, well, I'm just going to construct it for you while you guys finish up the pattern. If you wish to construct it with me, you may. So for the platinum rectangle, it's inside of a dodecagon. So I'm starting by folding it in half, unfolding, doing the same sort of 6-fold folds. And again, my corner on the slider. Now this time what I'm going to worry about is just bisecting and bisecting. So this, I bisect. And then this one, I bisect. So I unfold everything except that last fold, this last bisection. And where it hits, right there, that's where I fold the perpendicular. So I keep that folded up so that I have a reference. And then on the bottom here, I'm just going to make sure that this lines up to itself. And this thing right here, this is the platinum rectangle. So if one were so inclined, you could make a big enough of one that is big enough so that you can put the pattern into it. And then you could sort of, extend it. And what I mean by that is that this particular shape actually has a square, two squares, and what's left over is the height of a hexagon. Actually see that one hits this division, so that's a nice little thing. This is gonna hit that one. So the ratio of this rectangle is 2 plus root 3 to 1. So this right here, this is the height of the hexagon. And these are two squares. So we could install like this pattern we just did here, and then sort of extend it, and then finish off with another square. And this would all fit within reason, right? This would all fit here. So I'm just gonna show you real quick how this would look in like a construction. And so, well, for this pattern, it's sort of difficult to get it to be a 3D shape. Besides the rosette, of course, like we could get the center of the decagon to sort of pop out, and we could play around with that, definitely. That seems more doable. However, actually getting these shapes to be 3D, that seems to be more of a deal. Also, what you can do is you can fold the corners to the center like so. And you'll be able to see how the pattern continues. So I guess I didn't finish mine. So you get to see these shapes that we saw in the diagram. Well, this you can ignore because that's the one where I was trying to show the rosette that you can find in the corners as well. See this shape as well, this shape, the center octagon, the irregular octagon, and you get your half of the shapes here. And if you unfold, you get to see how those actually work. So if we actually just tessellated, this square is not that interesting. It needs this additional. Now this is a tile. This you could like put on tracing paper and extend infinitely, square by square. But I was suggesting that instead of extending it infinitely into a square, maybe extend it but onto a height of a hexagon. Maybe that would be more interesting. So I want to show you really quickly so we can move on. This thing that I have here. So that's, well, according to this book I read, this is called the Ring of Solomon for some reason. I'm not really sure. There's only one book, and it was a comic book, well, a graphic novel where that came in, so I don't really know. See, I'm going to construct a dodecagon here. It's pretty simple, on the computer. So now the silver rectangle, the platinum rectangle is pretty much just this rectangle.
Mm-hmm.
So if I mirror this, which is pretty much what we've been doing this whole time. This is why I use AutoCAD, because it just has a nice mirror function. I'm just gonna draw in.
Yeah. Take a screenshot.
So we have the Ring of Solomon, right? So what's cool about this one? Well, it's very useful for Islamic patterns in and of itself. So this is how it would look. This is what I mean by it's a height of a hexagon. Height of a hexagon and 2 squares. So if we installed our pattern into these points, so again, like we could, if we wanted to, find, like actually just construct this in here, you know, yeah, if we wanted to. What we just need is just the radial lines of the 12 fold. Just need then the half lines of this square. I'm going to translate these, move them on down. Oh, just making sure that they, no, this one's not. Never, you can never be too safe.
Mm-hmm.
So now we have it at that point, remember? Although I might be useful to have the full thing. Yep. All right, go for the full thing. All the lines of division. Again, it's easy when you know the clues, right? When you've done it, you can pretty much just solve it quite easily. Now we had there and there. So if we just drew a circle in, then again we can do the count. So we go 0, 1, 2, 3, 4. Just do the array function. This is what I love AutoCAD, really. Just make this go around 12 times. I missed.
I think that 0 and 1 were,
Yeah,
the fourth
different.
wasn't right.
Yeah, 1, 2, 3, and 4.
Yeah.
No, sorry, yeah. 0, 1, 2, 3, 4.
Mhm.
I think I drew a half star there for a second.
Yeah.
Yeah, that makes sense. That lines up. So all I'm doing really right now is just like, if I construct it on the square, I can sort of then extend it. And once I have my circle and my star, really, this is just really what it is. Oh. Let's see, what I've been trying to do is actually construct it on the hexagon, but I find that it's so natural to the square that it has to be, you know, that sort of relationship to it. So see, now we can just extend these lines and then bounce them off and then sort of, you know, we'd get it. But what I'm suggesting is that it's actually like this sort of rectangle that has the most sort of symmetry to it. I'll finish it up and then I'll send you a picture so we can move on to the next thing. But yeah, this is the idea of it. Yeah.
Yeah, brilliant.
So now we're here. We're back in with this thing. We did it by hand. We did it on our own, just with a piece of paper, no ruler, no compass, no nothing. But we are using the tool, the idea of it. And so when we feed our imagination with these ideas, we can sort of then maybe, perhaps, use those in other examples. So I'm going to put this aside for now. And I want to show you about twists. I want to show you how you can, this concept that I call consequence. The idea being that you can sort of get a single pattern, just like put one pattern in, and then from that tessellation, then you can sort of find which way to send it. Another ways to do it. So this is going to be a 6-fold pattern. So we're going to fold this in half like so. Open it up. Do again the corner to the center. See, now here's another way of mirroring. We have this line. We can just fold this line that appears before us from the other side. Now if we unfold that, we can see that same thing, bounce. But the overlap makes it so it's slightly off. So the thicker the paper, the more off it's going to be. So that's also why I don't always suggest just using the mirror, especially with a thick paper. But sometimes it's all we got. So we're going to do a third division. So we're going to divide into thirds this way and this way. So we're going to take advantage of this factoid that we had from before. So I'm going to turn it over. So the line that goes through them is a valley. Now in this case, I am folding the whole thing. I am folding the whole thing. I'm going corner to the top over there. Corner to here as well. So now, as you can see, we're sort of trying to get the lines to go through the triangle. So we're just missing one. And then its complement. So what's cool about sort of having more points or more lines on it is that you can sort of have faith that, well, for instance, here, this point, if that point matches, so if I put this specific point onto this one, there's only going to be one fold. So I can just put it on and then just. So now in order to get the thirds, what I need to do is just mind that center and put my corner onto it like so. Now, the fold I just did and this one on the triangle are parallel. These two lines are parallel. So I can just fold them onto each other. I can either turn it over and fold them, I can keep it like this, and just when I fold it, I make sure that the line falls on the line. You can see several relationships. For instance, you got this one, these match, this matches. Doesn't hurt to have it both ways. I'm doing a mirror. But you can, you can do it the other way as well. You can just see it's going through the center, and you're like, well, what's that? Well, you can always just fold that to the center. That'll help you find it. So now we have a couple more intersections happening. And the one I want to draw your attention to is the one found right here. So if I do a fold here, it's going to go right from this point upwards, from here to here. But when I fold it, I'm going to see that that falls exactly onto this point and on the bottom there. We can keep this going. So these sequences we're doing, we can then fold this half as well. And so if you look closely, you can see that we have 6 now. From edge to edge, from here to here, we have 1, 2, 3, 1, 2, 3, 4, 5, and 6 when I fold it. So we can keep this going like an accordion, or we can sort of start to see the intersections. For instance, we can see this intersection. See that that one hits there as well. See this one extends. Now what I'm looking at is that we have a line that wants to complete for these triangles. I'm also noticing that I'm still missing this line, but on this side. Now again, what I'm doing is just keeping the pattern going, just keeping these lines in check, making sure that I'm at the right intersection so that they can keep extending. So I'm minding my intersections. Mind. Now these, mind. Now it's most useful to have this thing go all the way. Just have this thing go completely all the way. That would be the best. But I might need to sort of streamline this and get it to a point where I can show you an effect, an idea, and then take it from there. So what I'm gonna do in order to do that is I'm gonna have to cut it at where I am. Now, you don't have to if you don't want to, but I'm just gonna show you an idea. So for that, I just need don't need that much. So I'm gonna keep it at, let's just say the end. This line that I've drawn here, this one is just gonna end for me. Now, because I'm using letter size paper, of course, this is not gonna match up, but these lines will match up. So these, so now let's say, for instance, I wanna try with you what I call a squash. It's not what I call it, it's just the way it is, but see, for a squash, you need a channel. So for instance, now I'm gonna use these 3 channels. So this channel's coming down, this channel's coming down, and this one's coming in. So you got all these 3. So I'm gonna push them all together like so. And now one of them, so all of them are gonna go in a clockwise motion. I can choose the other way, but it doesn't matter as long as they're all the same. So I put them together, and then one goes another way, one goes the other, and then you get that, right? The paper becomes tightened at the other end, sort of weaving it. And then what you can do is put 3 fingers on these 3 points and just start to bring it down. So that's a squash, and that really allows for further expansion, either by folding that in and then sort of doing an interchange, or you can just have this one consequence into another squash on the other side of it. You can sort of start to see how that happens. So we're going to take advantage of the fact that we have more than 3 squashes coming in, the 3 channels coming in, right? We have channel 1, 2, 3. Well, they extend all the way, but my point is that we can make, so instead of a triangle, we can make this a hexagon sort of channel. But we will need further divisions for this to sort of collapse properly. So we need actually a division that goes right through the center in order for this to just properly fall down. This is the way of the channel, right? Because if we bring this channel together with this one, we need a line that goes between them in order to access it. So the higher the resolution, that means the more lines we have or the more channels we can make, the more interesting the pattern is going to become. So for instance, right now, even though it's taken me, considerable time to get this far into it, and it's not that far into it, this is not very far. So this is also why when you see on Instagram or any other place like these patterns or these folds sort of drawn in, like they usually take a lot. The harder thing is to get the creases in, just to get your divisions in. That's the harder part. The fun part is to play around with the channels and the collapses and whatnot. So for instance, right now I have my 6 around the point, and I just need to mind my channel. So my channel is going to be right there. My channel is right here. But see, like the way it's folding and falling, either I need to be there, so I need to fold another line for the hexagon to work. Now the reason being that when this falls, this is going to need somewhere to fall. Like this channel is going to need, so I need like a slimmer channel, just because this is so much more expensive in a way. Like it takes more space. So see, when this falls, is now going to fall on this one. I'm just going to use these two. But that's the idea, right? It's to be able to come down to one side, but all at the same time. So even though that the channel does allow for it, it's so thick compared to what we're working with that we sort of need to put in another one. Especially when we go for 6s or when we go for 8s or something like this, it usually requires some additional channeling. So what's cool about what I'm doing right now is that I'm just augmenting my resolution. There's even more triangles now. So that's more channels, more to work with. And now what's also cool about having all these channels and all these triangles and hexagons and whatnot is that you can also choose the circuit of it. So there's some things that I call circuits. And that's pretty much just having your pattern and then choosing what's going where, and if it's raising and going down. So for instance, oh no, I need to show the channel. So one more. But see, can you see the shape that that I'm trying to get? So you can see the channels a little bit better. So when this comes together now, it has a place to fall onto. So same thing, but it's a hexagon. So instead of a triangle, it's now a hexagon. So now, since I have more sides and fingers, then what I can do is sort of start to pinch opposites and let go and go to the next one, next one, next one. And so as I do this, I'm sort of trying to be as regular as possible so that I can sort of then push and pull and push and pull. The more sides you have, the harder this becomes, but there's always a possibility of succeeding. And that just is about keeping your channels straight. So this channel is going to fall on these lines in the back there. So now instead of a triangular spin, I have a hexagonal spin. And again, like this channel or whatever channel, it can be used to harness another one. So at any point, I could then start to like see. So for instance, if I was so inclined to put another one there, which apparently is the center of a hexagon, if I had the same sort of channeling going through it, I could add it. So for instance, right now, the consequence that happened was that I went from a triangle to a hexagon using sort of the same channels, but now because it's even smaller, and if I wanted to now make this one triangular, like go back. So I went from a triangle to a hexagon, and now from a hexagon to a triangle, but it's so much smaller because I needed more channels in order to get a proper hexagon going. But now I have more space to put in my triangle. And then another possibility is when you do the next triangle, you can space it out. Well, of course, I would need to actually get this to be the same. So because it's not, that's what's making it difficult. Let's see, for instance, this is pretty typical though. Like in origami, you see this all the time in tessellations, the idea of twists and the idea of, I don't know, of consequence, but definitely of twists. It's like these twists are a big part of the origami literature, and how you combine them into sort of being coherent is also half of the work. So for instance, here I have them side by side. So like one starts to wonder if I could not have it be there and be somewhere else, like the same spin, but instead of there, maybe be over here. So I'm going to put it into position. And see, so it's almost the same thing, except that now I've gone down. So I have my circuit, and I can choose a point. I can choose a point of where I want this to sort of intersect, but I need this intersection. So whether it's triangular, square, hexagonal, whatever it is, I just need a point where lines are intersecting. And sort of this ability to sort of go under, up, and use those radial lines to benefit. So like the crazier one is if I augmented this resolution enough, I could actually put it like between. Like if I had another line between these, I could put my twist right halfway, and it actually would overlap. Like they'd fall like onto each other, and this could go into the other one and whatnot. So it gets pretty crazy. But see, for instance, these that have a separation between them, they have all this space that I can play with. They have all this space that I can play with. So for instance, those two, and then I could tuck them in. So that's just an idea of how, like, a possible consequence of this. It's a lot like using the squashes, except, you know, this is called a reverse, an inside reverse fold. So you do a fold and then you sort of tuck it into it like so. And so that kind of keeps it together. It would be interesting to see how this would look like once it's complete and all around. Like if this was a circuit, I did the same concept, but in a square. Let's see, where is this thing? Here it is. It took me a while last night to get it weaved. But this was like the same idea, but it was like squares that were on top of each other, like twists that were on top of each other. And I did the same trick where I got this to be inward. It took, this one takes, honestly, like it does take a little more trickery to it. So it's not maybe that natural of a consequence, but it's there. It's this idea that as you fold and progress, more solutions can come at you. So that's also a thing in origami, that even though something might look done, you might just stumble upon something even further. Like if you dared. So for instance, what I like about this one is that it has these tucks. So when you look at it from this other side, it has these twists of those squares as it opens up, and you can sort of see some rhombic shapes. But then these, it's very interesting because then these sort of like ribbons come out at you of what's underneath and what's on top. So again, this is the same thing as I'm doing here, but instead of triangles, these are squares. But it's the same thing. It's playing around with the weaves. And so just as much as this is weaving little squares and whatnot, this, if I kept
How big
going,
was your original paper on your square one?
like this one.
No, the one that you've just got, that one. Oh, it was that size. Okay.
It's that size.
Right.
Yeah, that's also like a thing, like it starts to crumple in. That's also a lot of what origami is or can be about, this sort of salvaging of space. So again, this was just a sort of a demonstration, and this is sort of like an encouragement. Last class, and this is going to be like a reshoot, of course, but last class we went a little bit different than this. And also, like, you can see the shape. Oh, I love that shape, actually. That's pretty beautiful. The last class, what we did was sort of like, again, do the thirds, but instead of going for this sort of squash around, I went into more detail of the squash in this time because some people were having trouble with that last class. But really what it was about, like, using the resolution, sort of finding islands. And last class it was, which was not recorded, which was going to be the reshoot of it, but trying to find other ways of connecting these shapes besides the channeling. Like, the channeling is very useful, of course, but other ways of maybe using what's on the page to sort of connect with other things on the page. So we're gonna have to leave that, and we're gonna put a pin on this for the next class. But before we go, I want to teach you something that last class we did. It's the modular. So the idea of these classes is that we look at an Islamic pattern. That's the idea. We look at an Islamic pattern. We look at a corrugation, or like the sequence of shapes. This is not quite complete yet, of course. I need to do more resolution on this. But like, yeah, a corrugation, an Islamic pattern, and a modular. So that's the idea of each class. Each class should have these three components to it. Although we did do this at the beginning. That's like a corrugation. So now I really like this ribbon shape. I will continue this one as well. So again, incomplete because of time, but will complete in post on Discord. If you're not on the Discord, let me share the link real quick before we move on. You're on the Discord, aren't you? I take that as a yes, but same, never know. Okay, we got a square piece of paper here. We're going to start by folding it corner to corner like this. Now we open it up. Now it's important to have some sort of congruency with this. So we got this in half, and then we fold this in half, like so. So again, diagonal and then the vertical. I'm going right now from top right to bottom left, and then vertical. And now between these two folds that I have, I'm going to turn it over. I'm going to put a valley between them. So again, what I did was I had my two mountains and then I put my finger between and put one mountain on the other, and same on the other side, mountain on the other. Now I'm gonna open this up. Do the same fold that we just did, but on the other way. So no using the other mountains, just this one. Now we have a long edge and a short edge. I'm gonna take the long one, I'm gonna put it onto this line here. And turn over. Corner to the top over there.
Can you do that again?
Yes, so it goes. We had the fold between the mountains, right?
Yes. Mhm.
And then we have a long edge and a short one.
Yes.
So we're gonna take the long one and we're gonna put it onto the fold.
Mhm.
And we're gonna turn the paper over. And same thing, we're gonna put long edge onto fold. And then we're going to open it to the side that there's nothing. And in here, we're gonna do the same thing. We're gonna fold this fold onto this line. Same thing here. Take this fold, and we're gonna put it onto that center fold we started with. Valley between the mountains. And so now that we're here, we have these and we tuck these back. Same for the other one. Now here, this folds back like so. We rotate and do the same on the other side. So now we have a parallelogram. These lines are parallel and these lines are parallel. And so we have what I call a slit right here. It's like the axis of symmetry, if you will. You're gonna take one corner and put it on the top. One corner, and put it on the top. And now you're gonna have this trapezoid looking thing. Now this design is by Tomoko Fuse and it's called the Bascetta Unit. So it's based on another unit by Paolo Bascetta, but it's this variation by Tomoko Fuse. Tomoko, of course, being the legend that she is, has to have this thing. So this design is quite popular in the Paolo Bascetta catalog. He has several modulars. So, you know, by consequence, by, you know, inference, there are several modular units that are called Bascetta units. So it depends on who you're asking. It'll be different things. So now that we have the trapezoid and we have the sort of like the long parallelogram, if you will, like this side of it. So we keep this one folded down, and then we fold onto the top there. Ooh. And we turn it over and we repeat. So now we've sort of extracted the rum that was inside of there. And with this excess that we have, we simply tuck it onto the top. And there's your Bascetta Unit by Tomoko Fuse. This is pretty much it. And the more you make, the better it's going to look, of course. So here I've been doing some these past couple days. This is 6 units. So this is like a tetrahedron. The one that I liked a little bit more, curiously has more volume to it, is the one that has 5 connected. So what's cool about this unit is that you can decide how many go around a point. So you can have 3, or you can have 4, you can have 5. So for instance, you can have 1, 2, 3, 4, 5. So you can keep adding them until you have a flat thing, if you will. But I find that after 6, it's not as sturdy. It's not that rigid. So now for this one, we'll tuck under the black and then go over. And what's cool about this is that it, like, all of them are sort of hugging each other. And see, once you have like this is like the way you close if you don't have enough to make a solid. You can start to close in on this side. So we pretty much covered the designs we covered last time, except maybe the corrugation was a little different. We added some more ideas, some basic sort of concepts on the mirrors. This one was also a mirror exercise, a little different, but we didn't see this one in this class, but same sort of concept where we have a line, we have some mirror lines, and we're bouncing off of them. Again, this could be used for something else, perhaps later. We did this Islamic pattern, this 12 fold on inside of a square, where we actually have the choice to make some more, stars on the corners, but we chose not to. We chose to go for this octagon with these shapes on it. These sort of I don't know what to call these things, but it's very interesting how we can still find a way to make these be symmetrical. So that's also quite interesting, I feel. And well, we also saw how once we draw the star in, you can actually fold this back and then just use the folds on this side to pass those folds onto the other side. So that was quite useful. And the corrugation we did, just sort of focus on this very basic idea of channels. Not that it's basic idea, but we just focused on the idea of, like, if we augmented the resolution enough of a pattern that is regular, like this, we have these triangles and these rhomбs and these hexagons and whatnot, sort of extract a certain fraction of it and then use that in order to twist and turn and make something more interesting out of it. And then something that could happen is that sort of the more resolution we do and the more we play around with it, the more other things are going to come at us, the more we might be invited to explore further and do things that are not entirely either obvious or easy. But it's quite rewarding. So I showed you an example that I did of the same sort of concept, but with the square. Sort of like this ribbon shaped thing. We went over a construction on the AutoCAD, which we saw the platinum rectangle. We saw the possibility of maybe putting this pattern, the one we have here, onto the square, and then continuing on to the height of the hexagon and then finishing off with another square. It's challenging, I admit, but I find that it would be very rewarding to see it all happen on the same strip of paper. Perhaps a little bit too much, but this is what we saw today. So thank God I recorded this one. So this one will go up and I will share with you, and I'll see you again on Friday.
Thank you very much.